Hello dear students, today we are going to talk about the first topic of the course of linear algebra, and let's start to talk about system of linear equations. This is the part 1 of this topic. This topic will be divided in 2 or 3 parts, I think. So this is the first one, and let's get started. Okay, a linear equation in the variable x1, x2, x3 till xn is an equation that can be written in the form a1 x1 plus a2 x2 plus a3 x3 and so on till an xn. This equal to b. This is the general form of a linear equation. As you can see here, for example, you have to relate what you knew before. One equation, you know that it can be written in this way. Ax plus ba equals z. Or another equation that you know, for example, 3x plus 1z equal 4y. These variables x, y, z that you know from previous equations that you saw before, for example, in high school, here in this general form are related with this x1, x2, x3 till xn. Can be any variables. Can be x, y, z, a, b, c, d, but have to be, they are known as variables. Okay, and in this general form of a linear equation, a and b are just constant. This b and this an, a3, a2, a1, they are known as a constant or coefficients. For example, a1, a2, a3, and so on till an, these are called coefficients. And b is another constant. These coefficients are also constants. These numbers a1, a2 till an, and b can be real numbers. Okay, this can be both real numbers or can be also complex numbers. That subscript n, this number, this n, is normally between 2 and 5, but in real problems can be between 50 and 5,000 or even larger. Okay, and that n is always a positive integer. Positive integer. Okay, this is the general form of a linear equation. As you can see, here the variables, this is the one variable, this is another variable, different than the previous one, this is another variable. These variables are not elevated with the power of something, are not affected with a root, are not multiplied between each other, they are just independent. This variable is here alone with its own coefficient. This also with its own coefficient. This variable is only affected by a multiplication with a coefficient. It's not to the square, it's not with a root, it's with nothing else. Okay, when the exponent, the power of the variables are 1, it's supposed that all these variables are to the power of 1, it calls linear, this equation. If this variable is to the power of 2 and this to the power of 3, then this is not linear. This is quadratic or cubic, etc. But it's not linear equation. Okay, that's why it's called linear equation. All the powers of all the coefficients from these equations are 1. Okay. For example, here we will see one example. This equation 4x1 minus 5x2 plus 2 equals x1. And this is another equation, x2 equals 2 times this number plus x3. These are both linear equations. Why? You can see here, at first eye, you can see here automatically that the power of every variable is 1. Here, this is x1 to 1, x2 to 1, x1 to 1. That's why this is linear equation. Here also is the same story. But if you want to do another technique to see if this is real linear equation, just you only have to show that this expression and this expression can be written in this way. This is the general way. If you can write equation in this way, any equation, then you can say, oh, this is a linear equation, because this is the general form that a linear equation have to have. So let's try. What we can do here is, for example, to rewrite this code, this x1 can go to another place, and is 4, we will have something like this, 4x1 minus x1 minus 5x2 equal, and this to another place, then we have here minus 2. Here we operate, and then we have here 3x1 minus 5x2 equals to minus 2. This expression is similar to what we have here as a general form of a linear equation. So in that case, we can say that this is a linear equation. The second equation, we can also accommodate this to multiply each term inside the parentheses. So at the end, we will have something like this. 2x1 plus x2 minus x3 equals 2 root square of 6. So then if we accommodate this, then we have x2 equals to no, that's it. This is the expression, the end expression of this equation. So as you can see, this equation was written on the form of the general linear equation should be. So in this case, we say also, oh, this is also a linear equation, because we could manage to write also in this way. This method is a valid one, but if you want to see in the first impression, in the first eye, if one equation is linear or not, you just have to see all the variables. Here the variables are x1, here x1, x2, x1. You see if they are affected only by coefficients. Yeah, this is only affected by the 4, this is only affected by the 5, this is affected by 1. And that's it. They are not elevated to the power of 2 or 3. No, it's only elevated to the power of 1. Every coefficient is elevated to the power of 1. So in that case, you can say also, oh, this is a linear equation. Similar in this case. Okay. Now here we learn what's a linear equation, how it can be represented in a general way, and some examples on how you can determine if an equation is linear or not. This is very important because later we will see a system of linear equations. So please keep in mind what's a linear equation and how you can determine if an equation is linear or not. Okay, in the next video we will see system of linear equations and how to solve the system of the linear equations. Okay, see you later.